14th lesson, part 3. Speed of a transverse wave in a stretched string. Students, if a string is connected to one support which is passing over a pulley and the other end of the string is suspended to a pan, and when there is no load in this pan, the string is not having the tension. String is not taut, T-A-U-T, not taut. But if you add weights here, what happens? By adding weights, what happens? Gradually tension increases. So suppose if you take two strings, one is having more tension, one is having less tension. Both are made of same material, same length, same cross-section, identical. Only thing is, one is having more weight, other one is having less weight. And if you apply some force, which vibrates more? Which vibrates more? While using guitar, veena, in between they used to tighten the strings. Have you seen this one? What they are doing? By tightening, they are increasing the tension. By increasing tension, they can produce sound waves of higher frequency, and higher they can produce higher velocity also. So this tension related to frequency of the vibration of the string. Frequency of the vibration of the string. So here, in this, if you apply some force here, if you just move it down, this is called putting, then a pulse will be formed here, and this pulse will travel along this one. This is called wave pulse. What is this? Wave pulse. Wave pulse. When a wave pulse is created, this wave pulse slowly moves like this and will come here. It travels along the string. Travels along the string. With what velocity this wave pulse? Can I call it as a transverse wave pulse? Is it transverse wave pulse? Why it is transverse wave pulse? Wave is traveling along x-axis, but the particles of the string are oscillating about y-axis, perpendicular to the direction of propagation of the wave. These two are mutually perpendicular to each other. So this is a transverse wave pulse. Suppose if a wave is produced, what is the difference between these two? Wave pulse means only half of the wave, lambda by 2. Suppose if a wave is created here, then it travels continuously. But first we will see about this wave pulse created, and we are finding speed of the transverse wave pulse in a stretched string. If the string is not stretched, pulse will not move that much easily. It takes lot of time for the pulse to travel from one end to the other end. Lot of time. Why lot of time? Because speed is less. When the speed is less, it takes more time to travel this much distance. So, how to find the speed of the pulse that is produced in this one, we will see. Speed of the pulse. Of the transverse wave. So, how to find the speed of this transverse pulse traveling along the string? To find out this one, students, I am just enlarging this portion. I am taking the small portion of this one and enlarging. I am drawing here. Is it correct? The same thing, this one only. I am drawing here. This is the wave, this is string. Stretched string after the pulse is created in this one. Let us say, this is theta, this is also theta. This is the string or the wave pulse. And let the distance of this one is dl. How much? The distance of this one? dl. We know, students, tension always acts along the string. How the tension acts? Along the string. We studied this in laws of motion. There, when a weight is hanging here, tension acts towards the point of suspension. So along the string, right? So how the tension will act in this string? Small portion of the string. How it acts? Along the string. Is this the tension? Is this the tension? As it is theta, so if you draw this one, see this is a right angle triangle, This is theta, this is 90, this is 90 minus theta. And as it is perpendicular, this is also theta. So this is T. What is this component? T. What is this component? T cos theta. And these two horizontal components cancel with each other. Why cancels? Both are equal and opposite in direction. These two will get cancelled. But what about this component? For T cos theta, this is T. This is also. So how many T sin theta are acting downwards? Both T sin theta plus 2 sin theta. So this force which is acting here, the particles of the string are in the form of a circular path, right? The particles of the string are arranged in the form of a circular path. These particles are not moving, but energy is moving. So for this particles to arrange here, a centripetal force will act towards the center. So what is the centripetal force acting here? What is centripetal force? 2t sin theta, correct? What is the centripetal force acting on that circular path of the wave pulse? How much acting? How much force is acting? 2t sin theta, equation 1. One more, students, what is actually centripetal force formula? mv square by r. F is equal to mv square by r. But what is this m? I am not taking the total mass of the wire. I am taking only this mass of this wire. So can I say dm into v square by r? Actually, centripetal force is mv square by r. But here I am taking a small portion of the string whose mass is only dm. dm into v square by r, equation 2. Can I equate these two? 2t sin theta is equal to dm v square by r. Can I write like that? Okay. Students, we have studied about this density. What is the density term? Mass by. So density is equal to mass by volume. This is called volume density also. Even though it is not mentioned, generally density means volume density. That is mass by volume. One more word that we are using today, linear density. Linear density, you know the letter mu. This is mass by length. Mass by. This is mass by volume. Mass by volume. This is called volume density. What is the length density or linear density? Mass by length. So mu is equal to total mass by total length, small mass by small length, very small mass by very small, dm by dm. Total mass by total length, small mass by anything. Now here, what is the total mass of this string? Only this portion. How much? dm. How to get dm? See this formula. Mu is equal to dm by dl. What is dm? What you can write? So in place of fc, I can write 2t sin theta is equal, from 1 and 2, 2t sin theta is equal to this, because both are centripetal forces. This is what is dm? First let me write dm v square by r. And here this is a very small circular path, then theta is very small. If theta is very small and measure in radian, what is sin theta? Theta. So can I write this 2t into theta is equal, here you can write here, theta is very small, therefore sin theta is, so 2t theta is equal to, what is dm? Mu into dl? Mu into, so I am writing mu into dl into v square by r. V square by r. This is equation 3. Now I am using this one. 2t theta is equal mu dl v square by r. But what is dl? Length of this element. Length of this arc. How to find length of arc? Radius into angle. What is the length of the arc? Radius into angle. What is the radius here? R. What is the total angle? 2 theta. Theta na 2 theta na. So I am writing 2t theta is equal to mu into what is the length of the top? Radius into 2 theta v square by r. Can you cancel r and r? Can you cancel this theta and theta? Can you cancel 2 and 2? Remaining terms? T is equal to mu v square. So what is v square? T by what is v? This is the expression for speed of transverse wave in a stretched string. What is this? In which type of strings speed will be more? See that formula, tell me. In which type of strings speed will be more? Speed is more if tension is more. That's why in between they have to, musicians has to type their strings, not their strings, guitar strings. Now, so V directly proportional to root T. Second one, V directly proportional to 1 by root mu or equal to mu. What is the meaning of this one? If mu is more, velocity is less. What is the meaning of this one? Mu more. Mu means linear mass density more. For same length, if mass, a wire like me, a wire like Prafulla, which has more mass here. Length same. Both wires have same length, but which wire has more length? So this I write M1, this is M2. Length same, L1 is L2. So can I say M2 greater than M1? I will write this as thin wires means. Thin wires. This is a thick wire. Proper wire, thick wire. Now, as the mass is more, lengths are equal. Mass is more for same length. Mass more means can I say mu more? Now can I write mu 2 greater than mu 1? So wait, the linear mass density is more here. Second wire has more linear density. More linear density means if a pulse is created here and here, which comes first? First one or second one? First one. The linear density plus. That's why in guitar, which type of wires they are using? Thin or thick? Thin wires. ಈ ಬಫ್ಲೋ ಯೂಸ್ ಮಾಡ್ತಾರೆ ನೋಡಿ ಹಗ್ಗ. If they use in veena or guitar, thick wire, and if you pluck it, you won't get music, you will get only bread. You won't get music there. So that's why in all musical instruments using these strings, which type of strings we are using? First one, tension should be more, linear mass density should be less. Thin wires. Okay? Solving a problem. So what is the velocity of a transverse wave in a stretched string? Root over T by mu. See this problem. Two thin wires made of same material. Rho1 is equal to Rho2. Volume densities are equal. Same material means densities are equal. Have lengths in the ratio of how much? What is L1 by L2? 2 by 3. And radius in the ratio of 1 is to 4. So I can write R1 by R2 is equal to 1 by 4. 1 by 4. Now students, as densities are equal, I am writing Rho1 is equal to Rho2. What is density? Mass by volume. So M1 by V1 is equal to M2 by V2. From this we can write M1 by, what is V1? Volume of the wire. Area into length. What is area? Pi R1 square into L1 is equal M2 by pi R2 square into L2. Can you cancel pi and pi? Do you know remaining values? M1 by, what is R1? 1 square into L1, 2 is equal M2 by, what is R2? 4 square into L2, 3. So now M1 by 2 is equal M2 by 4 square, 16 into 3, 48. So what is M1 by M2 now? 1 by 24. This is the ratio of mass of these two wires. One mass is M, other mass is 24 M. Don't say 1 kg, 24 kg. M and 24 M. Now I want to find out the ratio of the speeds of two transverse wave pulses produced in the one. So V1 by V2 is equal root T1 by T2 into mu2 by mu1. Students, in this they are under same tension. Can you cancel this? Now this can be written as mu2 by mu1. So what is mu? Mass per unit length. So I am going to write m2 by L2. What am I writing? Because this is mu2, so I have to start with m2 by L2 by m1 by L1. When goes up, L1 by. So what is the answer for this one? I can write this as m2 by m1 into L1 by L2. While solving these two problems, take care while writing these. Some students they are writing mu2, m2, L2, mu1, L2, m1. They are making mistake here. Be careful. So what is m2 by m1? Here I got m1 by m2, 1 by 24. There root 24 by 1 into what is L1 by L2? 2 by 3. 3 ones, 3 eights, 16 under root 4. So what is the answer? 1 is to 2, 2 is to 1, 4 is to 1, 1 is to 4. So this is 4 by 1. Answer option 3. This setup is called sonometer. Actually this is a table, students. This is a table. So for this table, at one end of the table they connected a pulley. On the other end of table they arranged a fixed support. And this one is the string. This one is the string suspended. One end is connected at this fixed support, other end is connected to a pad where a 1000 kg load is kept here. So in this case, if a wave pulse is created here, how much time will it take for the wave pulse to travel from where to where? Find the time taken by the transverse wave pulse to travel from where to where? Fixed support to pulley. So I will take this point as A, this pulley point as B. So what is the time taken by the pulse to travel from A to B? They are asking. That means they are asking time only. How to find time? Speed is equal to distance by time. Speed is equal to how much? Distance by time. So what is time? Distance by speed. If you bring this time here, speed here, time is equal to distance by speed. So to find out this time, I need to find out speed of the wave pulse and also the distance. So this distance from here to here, it is given as AB. Let us say this is 10 meters. How much? 10 meters. So first, in the solution, I need speed of transverse wave on a stretched string or not? Speed of transverse wave formula. Root T by mu. But what is the tension in the string? Tension is created by whom? This load. So here mg acting downwards, tension acting upwards. It is not moving at all. It is in equilibrium. So can I say tension is equal to T is equal to mg. So what is the tension? 1000 into 10. That is 10,000 newtons. The tension produced in this thing is 10,000 newtons. So I got T. Now I need mu. See the question. In a sonometer experiment, a string of linear mass density, directly they are given mu itself. So what is mu here? We got tension. Now I want mu which was given directly 10 gram per centimeter, but it should be in SI system. So I am converting this into 10 into gram 10 power minus 3 kg by 10 power minus 2 meter. These two get cancelled. 10 power minus 2, 10 power minus 3 get cancelled. You get 10 power minus 1 into 10. How much? 1 kg per meter. How much it is? Mu is equal to 1 kg per meter. T. So how to find this speed now? Speed of the transverse wave is equal to root over T by mu. So what is this value? The speed at which this wave was traveling from A to B is per second it is traveling 100 meters. But I just want only 10 meter distance. So now use this formula. Time taken to travel from fixed support to weight to only of length 10 meters. So I am using this formula. What is the formula? Time taken is equal to distance traveled by speed. What is the distance traveled? 10 meters. What is the speed? 100 meter per second. 1 by 10. How much? Within 0.1 seconds, the pulse will travel from A to B. A wire of length 20 meter and mass 100 kg suspended from a rigid support as shown in the figure. This is the rigid support. A thick wire, not thin wire. This is not thin wire, students. Not the wire that we are using in musical instruments. This is a thick wire because mass 100 kg means not an ordinary wire, very heavy wire. So heavy wire is suspended from a rigid support like this. What is the length of this string? 20 meter. What is the mass of this string? 100 kg. Now, find the time taken by the transverse wave pulse to reach the top of the string from the bottom. Let us say one transverse pulse is created here. How much time to take for this pulse to travel from here to here we are finding. Similar problem only. The string was horizontal. Here string is or wire is vertical. Better to write a wire instead of I am writing a rope. Wire means thin one. Rope. Thicker one. Okay. A rope. So now a pulse is created. How much it will take to travel top? Can you use the same formula? Time is equal to distance by speed. What is the distance to be traveled by the pulse? 20 meter. What is the speed? Root T by mu, right? V is equal to root over T by mu. So to find out that one, students, time is equal to x by V, x by root over T by mu, right? This is the formula. Do you know x? Distance to be traveled, how much? 20. Okay. Do you know the tension? Do you know linear mass density? First we will find out. What is mu here? Total mass of the rope by total length of the rope. Total mass 100. Total length 20. So this is 5 kg per meter. Every 1 meter mass of the rope is 5 kg. So I got mu and I know x is equal to 20 meters. I want tension. How to produce tension? How we produce a tension there? By suspending some load there, correct? In the previous problem, in a solenoid experiment, for the string, we are suspending some load by connecting a pan. But here, we are not connecting any external load. The load of the rope itself creates the tension. The weight of this one will create the tension. So here, at this top point, how much load is acting? 100 kg into 10 mg Allah. How much? Here I will take this point as A, this point as B. Otherwise pulse is traveling from top, bottom to top Allah. So let us say this is A, this is B. So what is tension at B? Tell me. How much? mg. That is 100 into 10. How much? 1000 newtons. ಅರ್ಥ ಆಯ್ತಾ? What is tension at A? ON on ಅಲ್ಲ, 0 newtons. Why 0? At this point what is the tension? Tell me. Is there any load below this point? Is there any load below this point? No mass, no load. What is the tension there? 0. So what is the tension here? Middle of this wire. Let us say point C. TC is equal to 500 newtons. Andre, this problem is not similar to the previous problem. In the previous problem, tension throughout the wire is constant. Here, tension changing from point to point. Whenever tension changes, speed of the pulse also changes. Speed of the pulse also changes. Initially, when tension is 0, speed is 0. That means this pulse is starting from rest. And slowly as it goes up, tension increasing or decreasing? As the tension increases, velocity or speed also increases. First we will see how that speed changes and how much time it will take, we will see. Students, artha ida? Why we are not using the previous formula directly? Because the tension at all points of the rope are not equal. It is not constant. So in this problem, tension is varying or variable. Tension is varying. So now I will take one point here, not exactly midpoint, somewhere. See, let the length from this one is x. Length this one is x. What is the tension at C? I am finding tension at one point. Tension at point C in bracket at a distance x from lower end, at a point, at a distance x from the lower end. I am taking a point C. Here first I am finding tension. So how to find tension? How to find tension? Tension is equal to small m g. Let us say this is capital M G, students. Total mass into G. But what is the mass of this portion? Small m. So this is small m g. So how to find small m? Students, we know mu is equal to m by x. Correct? This mass is small m, this length is x. What is the linear mass density of this portion? M by x. So what is m? Mu x into G. Understood? Mass of this portion of the wire is linear mass density into total distance. But what is mu? Total mass by total length into xg. What is mu? Total mass of the rope by total length of the rope into x into g. So this is the tension. This is a tension. Once you get the tension here, can you find out the speed of the pulse there? What is the speed of the pulse? Speed of pulse. Speed of pulse at C. Vc is equal root over Tc by mu. In general formula, speed is equal to tension by linear mass density under root. So what is the Tc? This is Tc. M by L xg by what is mu? So what is the speed of the pulse at point C? So this is the velocity. This is the velocity. Now what is the velocity here? Tell me. What is velocity at A? Root 0g. Why 0? X is 0. So velocity, speed will be 0. What is speed here? V at B, root Lg, total length L, Total length how much? 20 meter. Can I write this is 20 G? Root 200. 20 into G10 now. G10. Here I have to G is equal to 10 meter per second. So that means speed is also not constant. There in the previous problem, from that end to this end, speed is constant. But here, speed is changing from point to point, speed is changing. Because tension is changing, speed also changes. Now, I want a time. You take the students. Velocity at C is equal to root xg. But what is velocity, students? The rate at which distance is changing. Can I write this as dx by dt? What is speed or velocity? Dx by dt is equal to root xg. So dx by root x is equal to root g into dt. Now integrate on both sides. What is the minimum time? 0. What is the maximum time? That only we are finding. This side, what is the variable? X is the variable. Minimum value of x 0. Maximum value of x. Yalla. Total length of the wire. Total length of the wire. So now this I am going to do it. Dx root x when goes up. Root x means x power 1 by 2. When goes up. X power integral x power minus 1 by 2 dx is equal root g constant integral dt from 0 to 0 to L. Now x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Is it the formula? Integral x power n dx formula x power n plus 1 by n plus 1 with limits 0 to L is equal root g integral dt. Integral dt is t from limits 0 to t. 1 minus half that is root x. This is also 1 minus half and goes up. 2 root x. What is that? 2 root x from 0 to L is equal root g into t minus 0. Actually, what is this? T. Now suppose this value, what will do? Root 2 root L is equal to root g into t. So I need the time only. So what is the time taken for this pulse to travel from here to here? 2 root. This is the expression to find out the time taken by a pulse to travel from bottom to top of a row. This is the formula. But we know the data. We know L value, we know G value. Can you find out the time now? Time substitution. How to find out the time taken by this pulse to travel to reach the top of this one? T is equal to 2 root. What is L? G. 2 root 2. Root 2 1.414 into 2. 2.828 seconds is the answer. We will derive an expression for the energy of a wave. How to find energy? Total energy. Total energy is given by kinetic energy plus potential energy. Kinetic energy plus potential energy. So first we will find the kinetic energy of the wave and then potential energy of the wave. Then we will add these two energies. So before that, first let me take one wave. First I am taking string only. I am deriving expression for the energy of a transverse wave and formulas can be applied for only transverse wave in a string. Okay. Now this is the wave that is produced on this string. You can apply this energy wave for longitudinal wave also, don't worry. For all waves. I am taking transverse wave but applicable for longitudinal wave. Here, if you take a small portion of the wave, let the mass of this wire is m. What is this mass? What is this velocity? V. What is the equation of this wave? We know equation of the wave. What is that? This is y, this is x. So we can write equation of wave y is equal to a sine omega t minus kx. This is equation for displacement of a wave. What is this? But please remember students, every time y andre not only displacement, sometimes they may give equation like this: p is equal to p naught sine omega t minus kx. What is this p here? Pressure. Sometimes they may give rho is equal to rho naught sine omega t minus kx. What is this? Density. So density changing sinusoidally, pressure changing sinusoidally, displacement changing sinusoidally. Now the electric field symbol E is equal to E naught sine omega t minus kx. So electric field changing sinusoidally. Now sometimes they may give magnetic field, especially these last two formulas are used in electromagnetic waves or non-mechanical waves that we are going to study in second PUC. So this is B is equal to B naught sine omega t minus kx. Understood? Now these are all equations of wave only. Don't think that y is equal to a sine omega t minus kx is only equation of wave. This variable may be pressure, this variable may be density, this variable may be electric field, this variable may be magnetic field. So anything. This is, if these two are changing with time, then the corresponding wave is called electromagnetic wave. If pressure is changing, we call it as pressure wave. If density is changing, that is density wave. Why? Because in longitudinal wave, particles comes closer to each other. Particles comes closer to each other in a compression. So pressure increases. Next pressure decreases. So pressure increasing and decreasing, then increasing and decreasing, then increasing and decreasing. So pressure also changes sinusoidally. Similarly, in a longitudinal wave, when the pressure is more, density is also more. So how the density changes? That also changes sinusoidally. That's why this variable not only displacement, this may be pressure, density, electric field, magnetic field and something. So these are the waves. Now here students, first I am finding the total energy. Before that we are going to find out kinetic energy of the wave. Is given by Ke is equal half dm v square. Is this the equation? So why you are writing dm? Why not m? I am finding kinetic energy for a small length of the wave, for a small displacement along x-axis. Small kinetic energy for a small length. So now I am writing kinetic energy equation half. What is dm? We know for this wave linear mass density is equal to dm by dl, or dm by dx. Can you write like that? So what you can write in place of dm? Mu into dx. I will take this distance, small distance x. I will take this as dx. Mu into dx into v square. How to find v? We have so many equations. If you differentiate displacement, can you get velocity? Don't differentiate this one. You cannot get velocity. You have to differentiate only displacement. By differentiating this, with respect to time, you will get velocity of the wave, which is given by velocity v is equal to dou y by dou t. Why dou y by dou t? Previously dy by dt. Today I am telling dou y by dt. Yesterday I told you. Why dou? Partial differentiation. I am differentiating y with respect to time only. Others are constants. Here x is also variable. But if you are differentiating this with respect to time partially, this will become constant. Because x is a variable but constant when I differentiate with respect to time. This will become a sin theta will become cos omega t minus kx. I am differentiating this with respect to time, so this is constant. Now tell me omega t differentiation. Omega. So what is the velocity now? This is half mu dx a omega cos omega t minus kx. So this I am writing kinetic energy, a small kinetic energy, because this is kinetic energy for a small portion of the wave. dk, this dx also I am writing. What is dk by dx? Kinetic energy per unit length. What is this? Kinetic energy per unit length of wave, unit length. So dk by dx is equal to, remaining terms, half a square omega square cos square omega t minus kx. I got the kinetic energy. Equation 1. Now I need to find out potential energy. Then if I add those two, I will get total energy. So how to find the potential energy, students? We have so many types of potential energies in physics. Gravitational potential energy is the energy gained by the body when we do work against gravity. Elastic potential energy is the energy stored in a body if you do work against elastic nature of that body. And the electrical potential energy is the energy possessed by a system or body when we do work against electrostatic force of attraction or repulsion. But here, students, I am going to draw the same diagram here, that side. So from then we will derive the potential energy equation. First, before stretching, unstretched wire. What is this? Unstretched wire. This is y-axis. This is x-axis. Then unstretched means original length of the wire. But when a force is applied, by applying producing tension, let us say a wave is created like this. The same string got one waveform. Students, you could take a portion somewhere here. This is dx, right? Distance along x-axis. What is this? The same length dx elongated by this much dl. D. Artha agida? Same wire. Before applying any force, the length of this small element is dx. Once you produce a pulse, this length will increase. Dx will become dl. Understood? Now the same diagram I am drawing here, this one and this one. Bigger one. What is this distance? What is this distance? dx. What is this? dl. What is this? dx, dy, dl. Now, by using Pythagoras theorem, what you can write here? dl square is equal to dx square plus dy square. Previously, before wave is produced, this is the length of the small portion of the string. Now the length has increased to here. That means there is a change in length, right? When the wave is produced, this much length will become this much, slightly bigger. dx will become dl. dx will become dl. So now, how the tension is acting? Already told you, tension always acts along the length of the wire. Along the length of the wire. So who increases this dx to dl? Neva, nana, tension. So who is doing what? Work done by tension. What we are finding? Work done string. Students, how to find work done? dw is equal to t into ds. Work done is force and displacement. So work done is equal to force into displacement from work energy theorem, work and power lesson. work done is equal to force on displacement. Here in this, who is doing work? Who is doing work? Tension. How much? Tension into ds. What is ds? Displacement. What is ds? ಮೊದಲು ಇಷ್ಟಿತ್ತು, ಈಗ ಇಷ್ಟಾಗಿದೆ. So what is the displacement? What is displacement? Final length minus initial length. What is final length? What is initial length? So the work done is given by T into what is ds? dl minus dx. So this work done by the tension will be produced or will be stored as potential energy in the wave. That is du. I am writing directly. dw is equal to du. Tension T. What is dl, students? This is dl. Can write like this. dl is root over dx square plus dy square. That is only I am writing here. How much I am writing? dx square plus dy square minus dx. Got it? This is the potential energy stored due to the work done by the tension in the string to produce that wave, transverse wave in the string. So I am simplifying this one. du is equal to T into, can you take dx common here? Root over dx square common 1 plus dy by dx whole square. Understood? Check once. What is dx square into 1? dx square. dx square into dy square by dx square. dx square dx cancel. What will get? dy square minus. So du is equal T into dx square and the root. When it comes out dx root 1 plus dy by dx whole square minus dx. So tension is equal, if you take dx common, root 1 plus dy by dx whole square. This is in the form of 1 plus x whole power m is equal to 1 plus nx. If x is much smaller than 1. Much smaller than 1. So here also dy by dx is very very small. Square of this will be negligible. So what you can write now? 1 plus dy by dx whole square whole power 1 by 2. What do you mean by root? 1 by 2 minus dx. So this will become t into dx into, now it is in the form of 1 plus x whole power n. What do you get? 1 plus power will come here, half dy by dx whole square minus dx. So this will become t dx into 1 dx into this dx by 2 into dy by dx whole square minus dx. So this will become t into, this is du, students. du is equal to t into dx by 2 into dy by dx whole square. Can you bring this dx here? Because there also I got kinetic energy per unit length, here potential energy per unit length. So what is this du by dx? Half into, because 1 by 2, half into t into dy by dx whole square. Students, what is the equation of this wave? Y is equal to a sin omega t minus kx. So now what is the dy by dx? Right now dy dou y by dou x. Tell me, differentiate this. A sin theta will become cos omega t minus kx. Differentiating this with respect to x means t constant minus. Okay. So this is a dou y by dy by dx whole square. So what you can write? T by 2. What is dy by dx? This one whole square. A square k square cos square omega t minus. Even though we have minus here, square will become plus. So this is du by dx. What is this? Du by dx is equal half into tension into a square into k square cos square omega t minus kx. This is the du by dx. Is there any resemblance between dk by dx and du by dx? Whether these two are similar? Check once. This trigonometric function is same. Cos square omega t minus kx. This is also cos square omega t minus kx. But this term is different. This term is different. Students, we know v is equal to root t by mu. Do you know this formula? Squaring on both sides. V square is equal to t by mu. So what is t? What is t? Mu into v square a square. V is also equal to omega by k. Do you know this formula? Yesterday we did this one. Velocity of a wave is angular frequency by propagation constant. So here we have k. So from this, what is k? Omega square by v. Correct? V square is omega square by k square. K square is omega square by v square. So in place of k square, what you can write? Omega square by v square cos square omega t minus v square cancel. What is du by dx now? Du by dx is equal half mu a square omega square cos square omega t minus kx. Now tell me, is there any difference, similarity between dk by dx and du by dx? What is dk by dx there? Half mu illa. Mu is there, students. Mu is there. Mu a square omega square cos square omega t minus. So from this, what we can say? For a wave, potential energy for unit length, kinetic energy for unit length are equal. Suppose du by dx is 0. What is dk by dx? 0. But in SHM, when the particle oscillating like this, at top velocity 0, but potential energy maximum. At bottom velocity 0, potential energy maximum. Middle velocity maximum, potential energy minimum or 0. That is for SHM. But here, what we can write? dk by dx is equal to du by dx. Write down. Time out. While finding energy of wave, we know total energy is given by sum of k and pe. But here we are not finding total energy for entire wave. We are finding energy for a small element of the wave, small displacement of wave. So what I am writing? dE by dx. What is the meaning of this one? Energy per unit length of the wave. Total energy per unit length of wave is given by kinetic energy per unit length of wave, potential energy per unit length of a wave. Now I am finding dE by dx. What is the dk by dx? Half mu a square omega square cos square omega t minus kx. What is du by dx? Same only na? Half mu a square omega square cos square omega t minus kx. So what is the total energy of the wave for unit length? Half full. So mu a square omega square cos square omega t minus kx. What is this? Total energy per unit length of wave. Total energy per unit length of wave. Students, suppose if it is 0, this will become 0, total length will become 0. When it is possible, we will see in this. This is the original wire before wave is produced. What is this? Original wire. Then that wire string stretched due to tension, it reforms into a waveform. Here in this diagram, if you take this portion, what is this distance? Dx. What is this distance? Dx only. If you take a small portion here, small portion here, is there any change? No. That means at the crest of a transverse wave, what is this? Crest. At the crest of a transverse wave, there is no change in displacement. Change in displacement. Idu dx, idu dx. So what is the displacement there? 0. Displacement how much? 0. So when the displacement is 0, can I say potential energy will be 0? Why potential energy 0? Potential energy is the work done by the tension into displacement. Here displacement is 0. Where? Yet crest of a transverse wave, this displacement has not changed. This distance is same. There is no change in length. Displacement 0. That's why this will become 0. So here, what is du by dx at a crest? At a crest of a transverse wave, what is du by dx? 0. Then what is dk by dx? Why 0? This is also correct. Why? Because here particle oscillating like this. What is the velocity here? Particle oscillating like this. What is the velocity here? Here velocity 0. So kinetic energy for unit length also. So in a transverse wave, at crest, both dk by dx, du by dx are equal to 0. So can I write like this? dk by dx is equal, du by dx is equal to 0. When these two are 0, students, what is total energy of that wave at that point? So at a crest, the energy of the wave is 0. Now, I will take this portion. Here, whether distance changed or not, this is dx, this is dl. Whether length increased or not, this dx will become dl, length increased. Maximum extension, maximum displacement is here. Then if you divide into equal portions, students, this is the biggest length, then small, here there is no change. So where extension will be more at this point, and at this point extension more, at this point extension more, at this point extension more, at these points extensions are more. So then here can I say extension more in the string? Extension is more. Extension more means ds is more, displacement is more, then du will be more, du by dx also more. So where in a transverse wave at crest, dk by dx, du by dx is 0 and dE by dx also 0. But this is extreme position, this we call it as mean position. Mean position, dx is maximum, ds maximum means du by dx is maximum, dk by dx is maximum, dE by dx also maximum. Andre in a wave energy is not constant at all points. Here energy maximum, here energy 0. energy maximum, energy zero, energy maximum, energy zero. Understood? Energy is not constant generally by after in most of the cases. If you see the Bernoulli's theorem, if you see law of conservation of energy in the case of a freely falling body, their total energy remains constant. Kinetic energy changes, potential energy changes, but total energy constant. But here total energy is not constant. So total energy varies for a wave. For a wave. Now here I am taking a wave. This is the waveform. Let us say here energy model. This is a 25 joules energy. How much? Here energy how much? 0 joules. Here, 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 here. So now tell me whether energy, total energy constant or not. Total energy varying from point to point. Total energy varies for a wave from point to point. Next students, yesterday which is this one. Here this part will come down. Next wave will be produced like this. Correct? Wave ಸ್ವಲ್ಪ ಆಚೆ ಹೋಗುತ್ತೆ. Then next wave. Next one. So here total energy 0. After some time here this point will reach here. What is total energy? After some time you will get a wave like this students. ಅರ್ಥ ಆಯ್ತಾ? Now when we see for first time here total energy is 0 at crest. After some time this part will come down. This will reach this point. What is total energy? Here now maximum. After some time total energy. So what is happening here? Total energy at a point changing with the time. Now 0. After some time at the same point energy 25. 24, 23, 22, 21, 20, 19, 18, 17, 16 ಮತ್ತೆ 0 ಆಗುತ್ತೆ. Then 0 to 25, 25, 0. So energy varies between 0 to maximum. So what you can write? Total energy varies from 0 to maximum. ಯಾವುದೋ ಒಂದು ಟೈಮಲ್ಲಿ at this point energy will become 25 joules. At some time energy will become 0. Once again 25, 0 to increases 1, 2, 3, 4 up to 25. So energy varies in a wave from point to point, from time to time. From point to point as well as time to time. Is it clear students? So total energy varies from point to point in a wave. But from time to time it changes at the same position. At same position. Now, power of wave. Once you get the energy, can you find out power? Power of wave. I will write this as instantaneous power. P instantaneous is dE instantaneous by dt. Instantaneous energy by dt. Students, we don't know dE by dt in this equation. What we have? dE by dx. So how to get dE by dt? We have dE by dx multiply with dt by dt. I want dE by dt. Correct? I want dE by dt. Energy per unit time. Energy per unit time. So what I am writing? dE by dt into, can you write dx by dx? What is dx by dx? One is both are same. Now what is dx by dt? Velocity. Velocity of the wave into. So how to find the instantaneous power, tell me. Velocity of the wave into dE by dx. So velocity v only, I am writing velocity v. What is dE by dx value? Mu, no, half is gone. Mu a square omega square cos square omega t minus kx. This is called instantaneous power. By using the instantaneous energy, this is called instantaneous power. But I want the average power, students. You will know how to find average power in second PUC. I am just giving the equation. Integral P instantaneous dt by integral dt. What you are doing? Multiply instantaneous power with dt, divide with the integral dt, you will get the average power. So this is integral mu v a square omega square cos square omega t minus kx into dt by integral dt. Please remember, average value of this one, everything is constant. You mu constant or not? Linear mass density of the string constant. Velocity in a, for a progressive wave is always constant. Amplitude, because this is progressive wave, yesterday I told you, amplitude, velocity, frequency constant in first PUC waves. And omega, angular velocity constant. So this is the variable. So this variable value half. In second PUC max you will learn this one. The average value of this one how much? Half. So what is the total value now? Tell me. Half mu v a square omega square. This is the average power. Now intensity of wave. What we are finding? What is intensity of wave, students? I. This is the amount of energy passing through unit area normal to it in unit time. Unit time. Students, when I am speaking here, if you take some area here, this is area. Let us say area of this book is exactly 1 meter square. This is very small, not 1 meter square. So when I am speaking through this one, let us say this is a open area, not block area. This is completely closed. This area is open. So I remove this one. This much area is open. So sound wave is traveling through this area. If this area is 1 meter square, this area is 1 meter square, and in 1 second, how much sound energy will pass through this area? That is called intensity. So what is intensity? Energy traveling normal through a unit area in unit time. So formula, intensity, energy per unit time per unit area. What is intensity? We call it as Tivrati, intensity. Now, SI unit, students, energy by time, joule by second, watt per meter square. What is SI unit? Watt per meter square. Dimension formula, energy, ml square T minus 2 by time, ml square T minus 3 by L square, m T minus 3. L square also get cancelled. This is SI unit for intensity, dimension formula for intensity. Now I will find the intensity of the wave. How to find intensity? If you observe this one clearly, students, intensity of wave is nothing but power of wave by area. Why I am writing area here, spelling? Because amplitude is also A. This is amplitude square. This is area. So I am writing, what is power? Is this the average power? So I am writing half mu v a square omega square by area. But what is mu? Mass per unit length of the wire. So I am writing half mass per unit length v a square omega square by What is length into area? Volume. Mass by volume. Half rho V A square omega square. So what is intensity, students? Half rho V A square. Omega is 2 pi f or 2 pi by t. Can we do 2 pi? What is omega square? 4 pi square f square. 2 1 so 2 2 to cancel. So what is the intensity of a wave? Intensity of wave 2 pi square f square a square only. What is this? Intensity of the wave is given by 2 pi square f square a square rho v. 2 pi square f square a square rho v. What are the constants here? Once check matter. 2 is a constant, pi square constant. For a given progressive wave, frequency always constant, velocity always constant. Density of the medium through which the wave is turning is also constant. The amplitude of the wave may change. The amplitude may change. The amplitude, yesterday I told you, damped wave amplitude decreasing, but the frequency of the wave never changes. 2 pi is already constant. Density, velocity also never changes because it is traveling in a single medium. Sound travels at 330 meters per second in air. In air when it is traveling, its velocity is always 330. Here velocity. So from this what can write? Intensity equal to intensity more. Sound intensity more. What is the meaning of this one? I am producing a sound wave of greater amplitude. I cannot produce a different frequency. My body always produces a particular frequency only. By listening that frequency, you can identify. If I am taking class in some other class, by hearing that sound, you can say, Ramu sir is scolding somebody. But frequency, you know the frequency, but I can change my sometimes I am scolding in the ground floor, or I am giving some suggestion to the students in the ground floor. That the sound may not reach your class. Reason? I am producing sound waves of less amplitude. Less amplitude waves will die more easily. They cannot travel a long distance. But when I am producing a sound wave of large intensity means large amplitude. Here, when I am vibrating this one, students, this would always give same frequency waves. Can you hear the sound? You can hear the sound. Intensity is less. Why? Amplitude of the wave produced is less. Is there any change in frequency? No. I am producing same frequency waves. What has changed there? Amplitude. When amplitude is more, intensity is more.